Hello, welcome back. We're ready to do part 2 of section 2. We're going to start off talking about the factor theorem. Part 1 we talked about the remainder theorem. Here we're talking about the factor theorem. The factor theorem says that for any polynomial p of x, that x minus some constant a is a factor if and only if. If and only if. It's a factor if when you plug in a directly, you get 0 for a remainder. When you plug in a directly, whatever it is, you get 0 for a remainder. So let's test out the factor theorem. If, here's your polynomial p of x, is x minus 1 a factor? In other words, can you break down p of x and one of the factors that you break it down to is x minus 1? And basically, the remainder theorem says this. Remember, it says p of a will equal 0. In this case, we want p of 1 to be 0. In other words, when you plug in 1, either directly or synthetically, you get 0. Well, let's just do it directly. Let's just find p of 1 and see if we get 0. That'd be 2 times 1 to the 4th plus 5 times 1 to the 3rd minus 8 times 1 to the 2nd power minus 17 times 1 minus 6. And when you do all that, you get negative 24. So p of 1 certainly does not equal 0, which means x minus 1, what we started with, is not a factor of the original polynomial p of x. What that means is that this polynomial does not cross the x-axis at 1 because it's not equal to 0. What point would be on this polynomial? Well, negative 24 would be on it. When you plug in 1, you get negative 24. Alright, let's try x minus 2. Alright, let's try this synthetically, just to practice that. So, now remember, you don't put negative 2 in the hoopty. You put 2 in the hoopty. Alright, your coefficients are 2, 5, negative 8, negative 17, and negative 6. And we're hoping to get a 0 down here if x minus 2 is a factor. So drop your 2. 2 times 2 is 4. 5 plus 4 is 9. 2 times 9 is 18. 18 minus 8 is 10. 2 times 10 is 20. 20 minus 17 is 3. And 2 times 3 is 6. And ding, 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 6 minus 6 is 0. Boom. So p of 2 is 0. That means x minus 2 is a factor of p of x, the function p of x, which I gave you. That also means that on the x-axis, the function, if you graph it, will cross at 2. Will cross at 2. Okay, so here's a function. Now, it's raised to the 4th degree. It's a quartic function. That means there are 4 roots. Given 2 of the roots, find the other 2. I've given you 2, there must be 2 more. I've given you 2, there must be 2 more. So pick one of your roots, and what we're going to do is depress this polynomial. But we're not just going to depress it once, we're going to depress it twice. Alright, your coefficients are 1, 3, negative 3, 3, and negative 4. Make sure you're not missing any. 1, 3, negative 3, 3, and negative 4. Okay, do synthetic division. Now, you should already know what this number is going to be. I already told you negative 4 is a root. Based off of the factor theorem, if negative 4 is a root, then we should get 0. Alright, this was x to the 4th power. Remember that. Drop your 1. Negative 4 times 1 is negative 4. 3 plus negative 4 is negative 1. Negative 4 times negative 1 is positive 4. Negative 3 plus 4 is 1. Negative 4 times 1 is negative 4. 3 plus negative 4 is negative 1. Negative 4 times negative 1, positive 4. And ding, 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 we knew that. That means x equal negative 4 is a root. Now what you have to do is use the second root that we haven't used yet. But you don't use it with the original polynomial. You use it with the new polynomial, the depressed polynomial. And you have to depress it again. So what you do is you make a new hoopty. And in this hoopty, we're going to use our other root, x equal 1, that we haven't used yet. And we just repeat. Drop your 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 1 times 0 is 0, 1 plus 0 is 1, and 1 times 1 is 1 plus negative 1 is 0. Ding ding, we depressed it and we got 0 again. That means 1 is also a factor, but you already knew that because I gave that fact to you. Now we have a quadratic polynomial, and this says x squared plus 0x plus 1 equals 0. And here's the deal. Hopefully, this guy, once you get down to a quadratic, will factor. If it doesn't factor, then you can either take square roots, which is what we're going to do, or use your good old faithful friend, the quadratic formula. Okay, so this guy, the easiest thing would just be to add or subtract 1 from both sides. That's negative 1. So x is equal to plus or minus I. X is equal to plus or minus I. Alright, sweet. Well, I want to make one last little note here. That means we have two real roots up here. Two real roots. They're negative 4 and positive 1. And two complex roots, plus or minus I. That means that you could take this polynomial that is not factored, and you could factor it. Now, this is really important. To what? If x equal negative 4 is a root, then that means x plus 4 must have been a factor. If x equals 1 is a root, then it means x minus 1 must have been a factor. And then also, x plus I and x minus I are factors. That's how this function looks in factored form. You could have also said you could multiply those and get x squared plus 1. But either way, the point is I want you to see that that's how it factors. Now, another thing you can make note here. Now, this is a quadratic polynomial. If you were to sketch the graph, it has real roots at negative 4 and positive 1, and the other roots are complex. Since the leading coefficient's positive, both arrows face up. It probably does one of these if you graph it on your calculator. The point is, you only see 2 of the roots because only 2 of them are real. The other 2 were complex. Okay, so here's our last example. It says p of x equals 6x cubed plus 5x squared minus 3x minus 2. And your instructions are to find all the possible roots. Or, I'm sorry, find all the roots. And I made this one a little bit trickier because I didn't give you any of the roots to begin with. Last problem I gave you some of the roots. This problem I haven't given you any. So there's a couple clues that you can use. You can look at the factors of the constant. The factors of the constant are plus or minus 1 and plus or minus 2. And you can divide those by the factors of the leading coefficient, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. What those are the possible rational roots. If you take all these divided by all these, it's going to give you lots of different possibilities. There's a faster way to do it, though. I would graph it to get it started. To find the roots. So, let me pull up my graphing calculator. Okay, and oh, there it is. Alright, so I typed in this function. See it? Now I'm going to hit the graph button. And there we go, that's what it looks like. Now it looks like it's got a couple roots around negative 1. So what I could do is go to my table. So hit second, table, and look right there at negative 1. See, negative 1 gives me 0. That means when you plug in negative 1, you get 0. So, that's where I should start. I should start at x equal negative 1. We kind of cheated there, didn't we? We kind of cheated, but that's okay. So put negative 1 in the hoopty. X equal negative 1 in the hoopty. You don't have to flip it around. Your coefficients are 6, 5, negative 3, and negative 2. Now notice, we're going to get 3 roots. We've already found one of them with our calculator. Alright, drop the 6. Negative 1 and 6 is negative 6. 5 and negative 6 is negative 1. Negative 1 and negative 1 is 1. Negative 3 and 1 is negative 2. And negative 1 and negative 2 is positive 2, which gives us 0. Ding, ding, ding. That means x equal negative 1 is a 0. Sweet! But we knew that was going to happen because of the calculator. Now we have a depressed polynomial. Remember, he was x cubed. This guy's x squared. I got 6x squared minus x minus 2. Hopefully he factors. And he does. He factors to 3x minus 2 and 2x plus 1. So my other roots, my zeros, let me put zeros, or roots, are 2/3, -1/2, and then I found x equal -1. I found him earlier. Those are my 3 zeros. They're all 3 real, and they're all 3 rational. That means your factors, let's write it like this. We'll say the function p of x in factored form would be 3x minus 2 times 2x plus 1 times x plus 1. Those are the factors that would give you these zeros. This is the same p of x as what we started with, only now it's in factored form. It's not been multiplied together. So, synthetic division, pretty powerful tool. Helps you break these down quickly. And it's nice when the depressed polynomial factors. You didn't have to use quadratic formula. So, anyway. Well, that's all I got for part 2. Okay, I hope you have a great night. I'll catch you later. I'm out.